Hello, refrigerator.
Hey, yo, what's up, B?
Hello, microwave.
Oh, hello, boss.
Panini maker. God, I love being rich. Refrigerator, hand me the ketchup. Thank you very much. I love some ketchup after work. If only you could talk. My toaster oven. My favorite kitchen appliance. If only. Yes, hello? Oh, thank God you picked up. Listen, I need a new smart appliance for my kitchen. A toaster oven. I need it to talk, just like all my other appliances, and do what it needs to do when I tell it to do something. Also, I have trouble seeing all the little numbers on the knobs, and I need it to tell me what I input into it. Yes, please. I need the smartest technology. The Raspberry Pi. I want you to implement that into a toaster oven and make it smart for my kitchen. Can you do that? We'll see.
Boss, we just got an order.
For what?
Alright, boss, we need to make a smart toaster oven, and we need to make sure that it's easy for everyone to use, and it has to be
What do you think
smart.
I've been working on for the past year? Look at all this work. All this trash and all these failed experiments. I've been wanting a talking toaster oven since a year ago. The perfect design. A 5x3 box to hold all the software we need to program the perfect smart toaster oven. Look at these surveys. Everyone wants a piece of this. Our decision matrices have covered all of the brainstorming. External modification, what it should be made out of, the wattage, the Talk-A-Tronic, the name that we have come up with, the Talk-A-Tronic. It'll be a masterpiece.
Wow, boss, that's amazing.
While there already exists some technology, that just means we have rivals. We have people we should beat, people we should crush with our new invention.
The brainstorming process for the Talk-A-Tronic was just like many other devices, sitting down and spewing out as many ideas as we can with one common goal in mind. For the Talk-A-Tronic, that one common goal was a better toaster oven for visually impaired people.
Let's take a look, shall we?
Execution.
Throughout our interview with our mentor, we were able to gain valuable tips on improving the Talk-A-Tronic.
Hard to design, so I can't say,
Fair
it's
enough.
standalone.
Sorry?
Will it work if there's no internet?
I didn't even think about that. I'm not.
That's a big deal.
Yeah, Angelo and
Like Trevor, who's blind, he said, blind people know the internet goes down. Imagine you were in a house, the internet went down, and nothing worked.
Right.
You couldn't flush the toilet, you couldn't turn on the water, you couldn't turn on the lights, because your internet was down. They're using voice activated they depend on. The internet goes down, they can't use any of them. Yeah. So are you really prepared to enter that domain?
We want the Talk-A-Tronic's main consumers to be visually impaired people. Steve gave us suggestions on how to make it more appealing to them, and even suggest a blind person that could help us improve our product.
I have a blind person you can talk to,
right.
get
Yeah.
their feedback.
Can you get us in contact with?
I could try.
You can try. Okay. Thank you.
There's a North Carolina Assistive Technology Center you can visit, and they cover a broad range of people with special needs, certainly the blind among them, and they can probably find someone if you couldn't.
Okay.
I can talk to Trevor and see if
Yeah.
magic comes open.
Steve gave us many solutions that could help us with the Talk-A-Tronic and helped us create solutions to solve them, an essential part of the design process.
The top of the toaster oven itself, it says, like, caution surface is hot. I don't know if...
The plastic sounds... this plastic is melting at 180 degrees PLA.
Right.
Celsius.
I shouldn't be too worried about...
Oh, I don't know about that. I would be very concerned.
Oh, very.
I would test that right away.
Okay.
If it's going to be anywhere near coming in contact,
Yeah.
I can't say. You'd have to test it.
Yeah.
You can measure the temperature. You get one of those things that you can point at the surface and measure the temperature that way.
Mm-hmm.
And see, if it's getting up to 300 degrees Fahrenheit or something. He's tried many projects and then abject failures. Primarily, you said in many cases, they never talked to a blind person in designing it. Like, this company was clearly, like, you could tell in 30 seconds that they never consulted a blind person for the choices that they made. The high expectations, and they were dashed in 30 seconds a minute, or whatever. It's like, oh, piece of junk.
Yeah.
Basically.
I got
So
you.
if you want to get past that threshold, talk to blind people.
Okay.
Or seniors, special needs, or something like that. Tech savvy, I guess, I suppose. I don't know
He also gave us suggestions on how to make our product more unique versus other smart appliances.
It'd be nice, like, if you have the personal customization, like, if you could have a feature, this is asking a lot, but if you have a feature that, if you ask for it, it's saying, hey, toast my bagel, it does your settings, and if someone else, your mom asks for it, it says it's your mom, and she maybe wants to bagel a different toasting,
Oh, so like different settings for different people.
Right, if you could do the recognition of the voice and the command,
Okay.
and just automatically do that. That may be a lot to ask for, I don't know.
It might
That's
not
putting the cherry, that makes it convenient, because you think about these things, like, even though you have a voice interface, it's like you talk to it differently.
Mm-hmm.
They are getting better where it's more natural. It's darker, like, what does it mean? If it doesn't know you, toast my bagel to what? Now you got to say, make it medium light or something, or, whereas you probably say, oh, make it a little darker than yesterday. That would be convenient, right?
Yeah.
But if you have to remember, what was the setting yesterday? Oh, it was at 7, so make it 7.5. You got to remember that.
Yeah.
Which is a little detailed, specific pain in the butt.
Yeah.
You have to physically rotate that knob. You electronically, like, you can turn the oven on and off real quickly. And that's how you control power. It's dial to max, but you pulse with modulate. So if you want 50% power, the power's on for half a second, off for that. I don't know what that does to your power lines and everything else, but they run that.
Yeah.
It's like you yanking the light switch on and off, but it's a lot of lights. Other things might complain. You're just doing a prototype anyway.
Right, yeah.
But to make it so you're actually doing the control, that's a little bit of a challenge, and that's more than that's asked for. Mm-hmm. But hey, if you can make it work, awesome.
Steve did say that our large goals were a bit far-fetched. However, he did say that there are other great alternatives that we could come up with.
Or just gives you feedback in the knob position. Go to the next one where you're actually controlling it. That's a whole other can of worms,
Yeah.
I don't even know the level of complexity in that. And that's getting a little bit more senior. That's like in your thesis or grad student, I would almost imagine. So, but one other aspect you could have is something. Well, the original vision I had for you guys was that you could put this knob on something, and then there would be some procedure to train it, and then it would talk to a box that you put in the wall. And it would say, it was just speakers, so you didn't need the internet, you didn't need control. If you put another one, so you got multiple of these in the kitchen, or wherever it is. And so solving that multi-problem, I think is interesting. But to make it so it actually physically moves that knob or substitutes or something like that, that's a step up in my sense.
Yeah.
Presumably.
Oh, yeah.
Yeah, it's a much bigger project than just high school if you're controlling it.
Oh, is it?
I would think so.
Yeah, awesome.
I could be wrong. Prove me wrong.
No.
I'd be delighted.
We'll
We gotta be a challenge.
Well, yeah,
Step up.
we get this thing done. We're doing a higher than high school level project.
Right,
Yeah, that's even better.
Yeah.
Steve's ideas in mind, the 4 Talk-A-Tronic employees went straight to the drawing board. Using their past presentations, they were able to reflect on their progress. The meeting lasted for quite some time and finalized many ideas and problems. Here's a quick recap of the entire meeting.
So our product is going to be an add-on to a pre-existing toaster oven. This add-on is not any type of, do-it-yourself, add-it-yourself kind of thing. This isn't something that is mass-produced or anything like that. That we're not making the toaster oven. We have the toaster oven which we have purchased
and we are adding to it to give it the technology to make it smart, make it do things that a regular toaster oven cannot do.
The problem that we're trying to solve here is that the modern day kitchen is very difficult to use for the visually impaired and blind. The reason why is that many machines that plague the kitchen are visual feedback. They are not auditory at all. So if somebody that is visually impaired or is blind is trying to press the buttons on a microwave, they don't know what buttons they're pressing. If they're trying to set the temperature on the stove, they don't know what temperature they're setting it at.
It's pretty important to just flat out say we're not doing a microwave. We're doing a toaster oven.
The difference between us and them is that they are multi-million-dollar companies, and we're for high schoolers at an early college.
Two on the market right now are way more than $100, and not a lot of people chose 100 to 150, and some of them even go beyond 150. So ours will be between 50 and 100 if we do it all correctly, and so that'll easily apply to the vast majority of people.
But something we need to talk about is testing, and we need to basically just get that thing together as quickly as we can so that we can start actually testing how it works and what we need to change and whatnot.
Taught us nothing for this project. In a theoretical sense, yes, we've learned the design process. Yes, we learned like this is what engineers do. This is how engineers work. This is the environment, yeah. But when it comes to coding, we haven't learned a lick of that. When it comes to the actual mechanical, breaking open a toaster oven, taking it apart, rebuilding it, we haven't learned a lick of that.
Another amazing tool that we have at our disposal, considering we're doing coding and whatnot, is the internet. We have plenty of modules, plenty of videos, plenty of tutorials that we can look at.
So later on in the quote, it also says that we need to do research outside of the book, and when a book telling you how, or giving you a tutorial on how to use a Raspberry Pi and how to program Python tells you, you should also use resources outside of the book. You should definitely use resources outside of the book. So we're still going to have to do research further on than just the book itself.
Well, I mean, on a physical standpoint, we haven't been designing this thing at all. We have the box, of course, but that's just a box that we plan on putting things in. We have the chip, and we have the toaster oven, the speaker and wires and what all. We can get that pretty easily. So essentially, we have everything to do it, with the exception of the knowledge. That's something we don't possess.
I think we've got coding down. Is the actual mechanical engineering of wiring this thing up in a sense so that it works.
Mm-hmm. Yeah, and that's something I have a lot of experience with. I know that you guys have some experience with soldering as well, but I mean, for the BattleBot and the HockeyBot that I made before, I soldered so many wires. I don't know. I feel like the part that the thing about what we're doing is we're not like making a toaster oven from scratch. We're not doing anything like that. We're making a completely separate part and then hardwiring it to a pre-existing toaster oven. That's something that I feel like we're making the most important part of this project, and we're using previously existing tools or previously existing tools to help support us to the final completion of it. It's not going to be something that you personally add on to a toaster oven. It's going to be something that we hardwire directly to one. And that's what we're creating. We're 3D printing it. We're getting the Raspberry Pi chip. We're going to be programming on that. We're getting the speakers. We're soldering everything together. We're going to make this part functional and then make it work and coincide with a toaster oven, and to really have a product that functions well, that gives value to the person using it, you know. And I feel like that's probably the most important takeaway from everything that we're doing, you know. Yeah.